What you are looking at is a highly rare cluster of almost completely pure elemental iron which formed in association with Earth's worst known mass extinction event. On its own, elemental iron might be expected to be fairly common, as iron is the fourth most common element in the Earth's crust, composing 5.5% of its mass. However, since oxygen represents 47% of the crust by weight, almost every single piece of iron is bound to one or more oxygen atoms, which is best showcased in the three most common iron ore minerals: hematite, magnetite, and goethite. In other words, iron almost always will naturally grab oxygen molecules and incorporate them into a molecular structure, meaning that elemental iron is exceedingly rare. In fact, it is so rare that more tons of silver have been mined throughout human history than elemental iron has in the same time span. So, how exactly have these deposits of elemental iron formed in Bull, Germany, Eichhall, Russia, and Disco Island, Greenland? The answer is that through unusual processes, the Earth's geology created natural blast furnaces, almost replicating the process used today to extract elemental iron known as pig iron from iron ore. To create a high-grade piece of iron metal, you need iron compounds bound with oxygen, limestone, and a carbon-rich reducing agent referred to as coke, which is essentially heated high-carbon content coal in the absence of oxygen, all of which is combined and heated in a blast furnace. This process over time separates iron oxide into a compound which is generally around 92% by weight iron, referred to as pig iron. Well, the native iron found in several locations represents a naturally formed variety of pig iron in a manner of speaking. For this unique native iron to form, three items were needed: limestone, bituminous coal, and intruding magma which was rich in the iron compounds Fe2O3 and FeO. Thus, in all three aforementioned localities known to have native iron, there was once an intruding body of basaltic composition magma which was advancing upwards towards a layer of buried limestone overlaid by a layer of coal. For context, some basaltic magmas can contain as much as 7% by weight Fe2O3 and 8.5% FeO. When the magma hit the limestone layer, the calcium carbonate was partially converted into carbon dioxide and calcium oxide. Once this carbon dioxide interacted with the coal layer, it, along with elemental carbon, combined to form carbon monoxide. This carbon monoxide then combined with Fe2O3, forming Fe3O4. This Fe3O4 combined with additional carbon monoxide, forming iron oxide. And finally, the iron oxide combined with carbon monoxide to form elemental iron and carbon dioxide. These ores were placed not largely within the limestone like would be expected in a skarn deposit, but instead almost completely within the cooling basalt and gabbro. Remaining at depth and covered by now solidified igneous rocks, the elemental iron remained without becoming significantly oxidized. Two of the three aforementioned deposits originated due to a flood basalt eruption, as was the case in ancient Greenland due to the ancient Iceland hotspot, and in Siberia due to the unnamed ancient hotspot which formed the Siberian Traps flood basalts. Since the Siberian Traps caused the so-called Great Dying, wiping out 96% of all marine species 251.9 million years ago, it can be said that the Russian native iron deposit was formed in association with the planet's worst known mass extinction event. You might be wondering, if you were to find native iron in the field, how you might differentiate it with native iron found within iron meteorites. The distinction comes down to nickel content. Whereas an iron meteorite generally contains 10 to 30% by weight nickel, the 95% purity native iron fragments this video is highlighting were measured in one paper to only contain 0.06% nickel by weight. I want to note that these types of deposits are generally small scale, with very few occurrences involving more than 10,000 tons of ore. However, perhaps prospecting companies could search for them, as a scientific paper noted that these native iron fragments contain incredibly high amounts of germanium, which could be mined by itself for a profit, along with elevated cobalt, copper, tin, and nickel. As a final note, I would like to thank my new YouTube member Howie B for supporting this channel.